Was there any questions I missed online? Let me look at that because I think I would think they'd be on Wednesdays. I may have miscalculated that. Richard, if it asks you for that free trial thing, you may need to back out of that. And there's a link on the main learning modules, which goes just straight to the root website. And go to that and see if you can log in that way. And I think that goes away. Yes, I'll update those to reflect the current term. Are those, they might be off. Yeah, program one. Okay, I think yes, they should be Mondays because we have that holiday. That shifts it over. You basically, after I teach the material, you will have 1 week to complete the program. Yes, you do have to provide, Richard, you do have to provide your email. That's the way it figures out that you are at CNM. Yeah, and use your CNM email address. Correct, Laura? I need like another projector so you can all see the chat. That way we're all kind of in sync. No, I don't believe so, Jeremy. Well, my father came through, was in Arkansas, so I don't know if, let's see. Is everyone back? Yeah. Let me go ahead and move forward. So let's continue using the interactive interpreter and just type 2 plus 2 at the, and you should get 4. Does everyone get 4? So at the interactive interpreter, we can actually use we can use Python almost like a calculator. And if you type in a mathematical expression, then it'll just evaluate it. So put like two large numbers. They don't have to be specifically these, but just add them together, and you should get the answer as well. Does that work for everybody? Now, this is not really writing a program per se. This is just putting the expressions in and seeing the results come out. We're going to learn how to write a program later, but we can use this interactive interpreter to just kind of learn, little bits of how to write expressions, and then we can record them later. Yes.
So why don't I use parentheses to read that?
Because this expression is sufficient as it is. Well, in this case, we're not doing a print statement. We're asking the interactive interpreter just to evaluate it. And so if we write a valid expression, it will just evaluate it and echo it back out to the screen.
Mathematically, I couldn't write words up there.
Yeah, if you write words, it's going to try to interpret the words. Now, you could just put a quote and then some word and then a quote and hit enter, and you'll see it'll just echo that to the screen. So as long as and the reason why without the quotes doesn't work is because then it thinks it's code. Try this. Put 1 /2. And you should get 0.5. Does everyone get 0.5? So the slash represents division. So plus and minus is addition and subtraction. The slash and then the asterisk is actually used for multiplication. So now try this 1 /2. And what do you get? You get 0. The reason you get 0 is because what it's doing, forcing what's called integer division. And with integer division, what it will do is it will do whatever division you have, and then it will return an integer. And what's an integer? Does anyone remember doing number theory or anything like that in high school? Or the whole number. Yeah, the whole numbers, right? So 0, 1, 2, 3, 4, 5, 6, and the minus 1, 2, 3, 4, 5, 6 without any decimal portion next to it. So if you put a double slash, what you'll get is it'll basically do the division and then drop the remainder. And that can be useful in some instances. So they're all positive and negative whole numbers. Try these operations. 5 divided by 2, 5 double or integer division 2, 11 divided by 3, and 11 integer division 3. And you'll note that the behavior kind of is the same. Good question, Jeremy. which way does it round? If we notice the 11 divided by 3, notice, well, for the integer division, for like the 5 integer division 2, it's not actually rounding, it's truncating. So it's taking everything that's a decimal and just throwing it away. And yes, it will always be down in that instance, because if it's just throwing away the remainder, like if you do something that would end up with 2.6, it would end up still being 2 with integer division. And then notice that when we have, so what's the actual real answer for 11 divided by 3? It's 3.666 infinite. How much memory would we need to store a number with infinite precision? We would need an infinite amount of memory, right? To store all those infinite number of 6s. We haven't invented that yet, so it rounds. At some point, it just kind of truncates it, and it kind of is a weird thing here, because you think that it would be 6, 7, I think, but basically it actually just runs out of memory, and it just stops it. But that's pretty close. So whenever you do floating point math in a computer, you're never 100% precise. You're always kind of close. And what you're going to find is that the math in computers is kind of like the math you learned in high school, but it's not really math. It's more like a calculator. So try this. Say 1% 2. What could that be? And you get 1. Well, what this is the modulus operator. What the modulus operator is it's basically the remainder. So if you do 1 divided by 2, it's 0 with 1 remainder. And so you get the remainder, which is 1. The modulus operator can be kind of useful, because if you wanted to figure out, hey, every third one I want to do something different, you take the index of what that is. Take the index of that and take it with take the modulus of that with 3. If it returns 0, you know you're on the third element. So a lot of times where we have to have kind of every third, every fifth, or every eighth, whatever, we want something to happen, we use the modulus operator. So you're going to find that you end up using the modulus operator in programming a lot more than you would do in everyday life. Most of the time in everyday life, we don't really do much with this. But here, this is kind of useful for a number of things. So it's basically the slash is a division. The percent is, it'll give you the remainder after the division. So try these as well. Actually, you don't need to start a new Python command line window. You can do it in the same one. We just put 10 divided by 3, 10 modulus 3, 9 divided by 3, 9 modulus 3. And before you do these, try to predict what the code's going to result. And that's another thing that you can do when you're reading a book, is as you learn new pieces of code, type them in, and before you hit enter, just try to predict what it's going to do. And one that there's a thing called paper compiling, and when I initially learned how to code, I had a book and I had a computer in the school, but I didn't have one at home. So what I would do is I'd write out a layout of my program as pseudocode, and then I'd write that program based on that pseudocode. Then I'd give myself a little time, and I'd take a piece of paper and I'd run through each line of code, and I'd write down what the memory variables were as they changed and what the output was as it occurred. And if you can do that, and then you run it, and then it's identical, then you kind of know that you understand what the computer's doing. So if you want, that's, as we get a little further along in programs, you can go, there are some sample, I have the website for the book, and I think I have them downloaded there. You can look at sample programs and just try to paper compile them and see if you can figure out what they're going to output. Or if you look at the sample code in your book, try to run through it and paper compile it, and then see if when you run it, you get the same result. So what you should see is this: the 10 divided by 3, we got 3 repeating, and again, it's kind of and then the remainder, or it ran out of memory, and then 10 mod 3 returned the remainder of 1. So 3 goes into 10, 3 times, which is 9, with 1 remainder. And then notice the last one, 2.75 mod 0.5. What happened there? Why is it 0.25? Well, think of it this way. If with the integers, we basically take the one on the right, divide it into the one on the left, and take whatever the remainder is, let's do the same thing. How many times does 0.25 go to 2.75? I don't know, but it's probably something, it'll end up being 2.5, right? It goes into it 5 times. 5 times 0.5 is 2.5. And then the remainder is 0.2. If I take 2.5 and subtract it from 2.75, I get 0.25. Does that make sense? So 0.5 goes into 2.75 5 times with a 0.25 remainder. So it's just doing the same thing. And you're going to see this constantly with Python. They wrote the language, and basically they said, hey, you know what? If this is what we're going to do with integers, let's just do the same thing with every number and just let it be what it does. And so the algorithm for doing modulus arithmetic on floating points is the same as integer. Now I'll try this, 2 asterisk 3. So, in keeping with the scheme, what do we think this might be? It's another valuable skill learned as a programmer is realize, there's only certain math operations, right? What would we use this to represent possibly? And at a certain point, you might start being able to guess what the syntax is. And after you learn 2 or 3 languages, actually, you start going to other languages, and you almost don't need to learn them that much because you just start seeing the patterns. So, if we think about this, well, and the result. And so what do we think this is doing? What's that? Yeah, exponentiation, raising 2 to the 3rd power. 2 times 2 is 4, times 2 is 8. So 2 to the 3rd power is 8. So yes, that's how we do exponentiation in Python. If you want to raise something to a power, you can do it that way. And then try this. And try to predict what this will be. -3 raised to the 2nd power, and then -3 in parentheses raised to the 2nd power. What should that be? What's -3 raised? What's the square of -3? 9. Positive 9? Yeah. So that's what we would normally expect with normal math. What do we get? Yeah, we get -9. So in order of, everyone familiar with the order of operations in math? Which comes first, exponentiation or addition subtraction?
Exponentiation.
Yes. So computers need things to be simple. So it does it in that expression up there. It does 3 raised to the 2nd power first, and then applies the minus sign. So then to fix that, what we do is we put the minus sign, -3 in parentheses. What do parentheses do with order of operations?
First.
Yeah, it makes it sets priority. So now we're going to make it a -3 first, and then we'll raise it to the 2nd power. And we get the and we get the right answer. So I said it's kind of like math, but not really. And so we have these little idiosyncrasies. All right. So those are expressions, and you could, we could do all of our programs as one big long expression, with a print statement at the beginning, and it would be cumbersome. So we need to, a lot of times, do calculations and store the intermediate results into a place in memory. Everyone know how a calculator has like a memory plus and a memory minus, or if you have a really cool calculator, it might have multiple memory storage locations. A variable is just like that. But imagine that in addition to just having like specific memory sources, you could actually have as many memory locations as you want, but the only key is that you have to name them. That's what a variable is. So a variable is a name that represents or refers to some value. And really what it is it's indicating a place in memory where you're going to store some information. That information could be a string, like our hello world, or it could be a number, like either a floating point or a integer number. And this is how and we use the equal sign. So this says x equals 3. And then and you notice when you do that, it doesn't return anything. Unlike other expressions which return something right away, this is really a statement, not an expression. And so statements basically will just do something. In this case, it says, okay, I'm going to take the number 3 and I'm going to make a location in memory. I'm going to call it x, and I'm going to store that 3 in that location in memory. That's what's really kind of going on. Conceptually, you could say x is this thing that's going to hold some values, and initially I'm going to make it be 3. Later on, I could do another equal statement and make it be something else. I can change it as many times as I want. But right now, I'm saying store 3 in x. And so, is this really like mathematical equality? Not really. This is really what I would call assignment. We're assigning the value 3 into x. So whenever you see an equal sign in programming, I recommend you say to yourself, assign 3 into x. So put it as assign something into a place in memory. With an assignment variable, the thing on the left is invariably going to be a variable because you're storing it. It's used to store things into memory. So you can't say, for example, 3 equals x. It wouldn't be able to do anything with that. Thing on the left has got to be a variable. Now put x and what you get. Does that make sense online? Cool. What do you get when you put x?
You get the value that's stored in there, but why don't you need to use prints?
Later on, when we're writing programs, we will need to say print x. But as we're using the interactive interpreter, if we put an expression, it'll just go ahead and tell us what's there. So x has the value 3 in it. Now say x times 2. So the asterisk is the multiplication. And try to predict what it's going to output. You get 6. Now here's a question. What do we think is going to be stored in x? Is it going to be 6 or 3?
3 still.
Yeah, do an assignment into x again? No, there's no equal sign there. Nothing has changed x. And this is actually something that's somewhat hard as a new programmer to understand is, unless there's an equal sign, you're not really changing anything in that variable. So here we're using it, but we're not actually changing it. And so if you look at x, it's still 3. If you wanted to change it, you could say x equals 4, and then it would change it. But until we actually do another assignment, it actually change. So there we use a single letter, but you can use more than one letter. In fact, you should. Your variables could be letters, digits, and the underscore character. Another rule is a variable cannot begin with a digit because then it starts trying to process it as a number. So it's got to start with a character, but you could say plan 9, for example, but you can't say 9 plan. And you can actually start with an underscore if you wanted to. We often do for specific reasons. So normally we use characters, and we'll often use compound words like first name, and we'll capitalize the F and the name, or we'll keep the first character lowercase, but every subsequent word will have a capitalized letter. And that's called camel casing or Pascal casing, as the case may be. But you'll see, as you see the different code, you'll see that that they do that with the variables. And the reason why we want our variables to be verbose is this helps us read the code. It's relatively easy to write code that works. You'll disagree with that until towards the end of the semester. But generally speaking, once we learn how to write code, it's easy to write code. The hard part is actually writing code that we can understand later and that someone else can read and understand. So if you use verbose variables, then it's easy for someone to say, oh, I know what that is. Imagine if you were to just use A, B, C, D, one after the other, with no rhyme or reason, and just made your variables all that, and you had all these calculations on page. No one would be able to maintain that code. So using very descriptive identifiers for your variables and for your program and your functions can almost make your code read like a story. And if you do it well, someone should be able to read your code from top to bottom one time if they're a programmer and understand what it is. If they have to go back and forth all over the place, I call it like your code reads like a detective novel. And and I have had most code out there is actually kind of messy. And so it's interesting how much you burn hours just trying to figure out what's going on with a piece of code. And that translates into money. Developer hour to a company costs maybe $100 to $150 an hour. So you imagine if it takes them 2 hours to figure out what's going on, well, they just burn $200, without actually producing anything. So the clearer you can make your code, the much more valuable you are. So, okay. Statements. So most of the things this x equals 3 is what's called an expression, or it's called a statement. And it's different from an expression that when you type it at the interactive interpreter, you notice it doesn't return anything. So the interactive interpreter does not evaluate statements. It only evaluates expressions. And this is kind of a weird concept. If it doesn't make immediate sense, it may be something that makes more sense later as we start writing code. But for example, here, if we say x equals 3, and you wrote this, I think. So, nothing was returned. But then we said x, this is an expression because it actually returns something that the interactive interpreter. We say x times 2, that's an expression. It's evaluated and the interpreter displays it. When we go to writing programs, the expressions actually won't be displayed automatically. We'll need to have to explicitly use print statements. But for now, there is a little bit of difference here when we do expressions and when we do statements. Now, print is kind of a weird exception here because when we say print, and you already did this, you don't have to type it in again, it actually displays something. But this is not, print is actually a statement. It's not an expression because print just happens to be a statement that says put something to the screen. So we're going to get into writing programs because that interactive interpreter thing is cool, but let's say that you write some really cool code that way and someone else wants to use it. It's really, really inconvenient if every time they want to do those calculations, you had to come over and write that for them. So what we really want is we want to be able to write it down one time and then someone can just execute it. That's what a program is. It's basically a text file with a list of those expressions and statements that we want the computer to process. And when we write programs, if we want anything to display a screen, the only way we can get it to display is by writing print. So we have to write a statement that displays it to the screen. So we're going to look at that in a bit, but one of the things that we need, so right now we have the ability to do calculations. We have the ability to display things with print. The one thing that we're missing is the ability to get information from the user. And we're going to do that with an input statement. So do this, type in input, like the universe and everything, and hit enter. And it should print out. And you'll probably have a blinking cursor at that point. This string between the quotes that's being passed to the input statement, basically what this will do is it's very similar to the print statement in that it prints out whatever that string is. But the other thing the input statement does is it sits there with the cursor and waits for the user to input something. So go ahead and type in 42. I'm getting my references crossed here. That's really the answer. I guess that is the answer to life, the universe, isn't it? Yeah. So 42 is the answer to life, the universe, and everything. We don't have the question, really, but we have the answer. And you'll notice that after you hit enter, this input statement echoes back 42. So the input statement is actually kind of an expression as well, because it returns back a value. Now, that's cool, but there's a problem with that. Is, okay, well, how do we use that 42 later on? The other thing to notice is what's around the 42? Single quotes. By the way, single quotes and double quotes are the same, so you can use them interchangeably. So it gives you back the number 42, but it's not a number. It's actually characters 4 and 2. Input will bring back a string. So what we need to do with our input statements is actually we need to store them in a variable. So whenever you write an input statement, you're going to write the input statement, you're going to have an assignment, and then you're going to put a variable there to catch the results so that we can use them in our code. So try this one, x equals input, and then the prompt is going to be, just simplified x colon. And so now you have the prompt and you have the cursor blinking there. And when you get that, just type in a number. And then type in another variable, y. We'll do another, but there's no necessary relation between this prompt and what's here. But normally what we choose to put in here is something that tells the user what we want. And this is not actually a very good prompt because we don't know what the values were. It really should say insert y in meters or feet or something like that. But then put in 42. And so now, then we can say print x plus y. Notice here, before when we did a print statement, we said print a string, but here we're just putting an expression directly in there and say print it. And what do you get? You get 3,442. So the addition, so that makes sense, right? 34 plus 42 is 3,442. No. What did it do? Yeah, just put the two strings together. You can't actually add strings together. It just puts one next to the other. So that would probably take me a month to figure out what's going on if I didn't know. So actually, and I should have put the solution here, what we have, I think we learned to do that later, but I'm going to give the answer because otherwise it'll drive people crazy. So try doing this. X equals So we can use this command either float or int. What the float will do is we'll convert whatever we brought in here that comes in as a string, it'll convert it into a floating point number. So that work? Do we get a better answer? So if we put x equals float, I could do this. Then I get a decent answer. Does it make sense? So, and basically the idea here is, if I say float of, some value, it'll turn it into a floating point number. If I say int of some value, it'll do that. It'll be interesting to see if I do 345 or 35.45. What does it give me? It can't convert that to an integer because it's not an integer. But basically, you can use float or int to convert things into numbers. So when we're doing input, if we want a number, we got to specify if we want float or int. If we just want a string, we just do the input. Does that make sense? So that actually gives you a lot that you could actually play around with now, because you could do the inputs. Let's say if you want to make a calculator that multiplies numbers, you ask the user for value 1, value 2, and then do the multiplication. So that's all we're going to do for today. Next time we're going to learn how to actually make a program with this stuff, and we'll move on from there. And I would say next step is read through your book and maybe go through and, open up a program and, install Python at home if you don't have it installed yet, and just pound with the code up to here. A lot of it will be replicating what we've done so far, but you can move on ahead or just play with the code. And that's all I have for today. If there's no more questions. Any questions online? Yes, Jeremy, you can actually make websites with this. There's some frameworks like Django, which is DGANGO, and Flask is another one. Which are libraries are designed to help you make websites. We won't go into that, but you could actually go to the websites and run through the tutorials. They're pretty involved. Actually, making a really involved website takes quite a bit, but it's a really good skill to have, and there are companies out there that actually do Python programming for their websites.
So Django, I'm assuming it follows like the model view controller thingy.
Yes, they use a slightly different language on how they phrase that. It's like model view presenter or something like, or model view. Yeah, and like what they call the model is actually like one of the terms is switched, but it is exactly the same pattern.
Do they also use JavaScript for
Front end.
the front end?
Yeah, they kind of have to.
That's what I-
Yeah.
JavaScript
You
is-
cannot get away from JavaScript.
That's why I'm trying to do JavaScript now.
Yeah.
You pretty much have to do.
I mean, you can do a lot, but at some point, you know, and especially with the services architectures that they're doing now, you will make a web API like we did. That, you know, the Angular. Well, no, we did JavaScript front end and then a web API back end. That's becoming very popular because it moves a lot of the workload off of the server and puts it onto the client. And
So did you ever teach JavaScript?
yes.
Was it last semester though? Because I didn't see any.
Oh no, I haven't taught a pure JavaScript class, but in 2284, I do a little bit of JavaScript.
I looked on the electives and apparently there's like a JavaScript web development class.
Yes, that's on the web programming side. They do have a JavaScript course. And I spoke with them. I said, hey, is there a good follow-on for 2284 students to go on to learn more? Do we have something that gets into the more JavaScript side? Because once you understand the JavaScript, then you can probably pick up Angular and or React. Those actually make it a little easier. But I think first it's good to just have a good grounding in JavaScript. I'd like to see like I'd like to see the Stimulus Center offer like a little after hours week-long Angular course and then a React course. I think that would be very popular. I think they'd like to, but I don't know if they have enough need. If they see, they're concerned probably about how much demand they get, but it's really needed out there. Is to spin people up on things like that. Another thing you could consider doing is, if you grab a bunch of people together and you want to meet like at Hackers or something, I'll put together, we can like all go, work together to pick up a skill set, and you all decide, hey, be interested in like learning React. We'd like to spend some time, figuring that out, and we'll just go through the documentation. We'll give ourselves, little tasks, and we'll do it. Maybe even like over the summer or during a break or something. I'd be willing to do what I can to support that. You make it like a meetup. Yes.
Okay, so I get lost because I'm a very poor typist.
Oh, okay.
Yeah, and so I was wondering here too, where it says in the black part, the Python part, you've got the command prompt and int parenthesis quote 35.45, and that
Yes.
doesn't work. If I put inside